Hello and welcome to this video. So in this video, I'll be talking about AAA Principles and Configuration, and I calling it AAA Principles and Configuration. The first A stands for Authentication, the second A stands for Authorization, and the third A stands for Accounting. So what is this about, and why is it important in our coverage of telecommunication networks? Well, user management is one of the most basic security management requirements, at least for any network. For each and every network, beginning from the network administrators who log in to configure stuff on the network, up to the network services users who log in to consume services that we provide on our network, we need some kind of network management. So we use authentication, authorization, and accounting as a management framework that provides a security mechanism for authorizing some users to access specified resources on the network and then recording the operations that these users are performing on the resources they are authorized to access. Authentication, authorization, and accounting is widely used because of its good scalability and easy implementation of centralized management of user information. So, AAA, authentication, authorization, and accounting can be implemented through multiple protocols. Now, in actual situations, the remote authentication dial-in user service, also called Radius, you'll see this a lot. The Radius protocol is the most commonly used to implement AAA or AAA. Now, in this chapter, we describe the basic concepts, the implementation, the basic configuration, and typical application scenarios of authentication, authorization, and accounting. Upon completion of this chapter, you'll be able to understand the fundamentals of AAA. You'll also be able to describe the application scenarios of AAA, understand the fundamentals of the Radius protocol, and get familiar with basic configurations of authentication, authorization, and accounting. In order to aid you in understanding these four objectives, I'm going to split this chapter into two parts. First of all, I'll talk about the AAA overview. We'll talk about what authentication is, what authorization is, and what accounting is, and which modes of each of those do they support. And after that, we shall look at a typical AAA configuration commands, how they get used, and where they're applicable on our typical enterprise. So let's get started with the basic concepts of AAA or AAA. So AAA, as I've mentioned, stands for authentication. This is the first A, authorization. This is the second A, and accounting is the third A. And it provides a management mechanism for network security. Now, there are three A's, but I'm going to explain them in four steps. So what happens when you try to access a device? What happens when you try to access the closed down parts of a system, an intranet or something like that? The first thing that is going to happen is a pop-up that asks you to enter your username and your password. Now that is what you call user identity. You'll identify who you are. I am John, and this is my password. Now, when you identify who you are and input your password, you're trying to say that you are sure and you're proving to be the person you claim to be. Now, the system in step 2 is going to authenticate you. The system is going to verify that you are actually John, and this is indeed your password. You are the person you claim to be. The system needs to authenticate you before giving you access to resources in the system. After confirming that you are actually John and indeed this is your access password, it will give you authorization to access the parts of the system that you're authorized to access. Now, in a banking hall, for example, there are some places where only staff can enter, and there are some offices where only staff with a certain card can get into. Not everyone who is working in a bank can get into the data center, for example, the IT room. Not everyone can open a rack and change configurations. So you'll be authorized to access only the parts of the system that you're supposed to be able to access. That is what authorization is about. It determines whether the access is granted authorization. Yes, you are John, and yes, that's your password. But what are you allowed to access in the system? That is what authorization is about. And once you get access to what you're permitted to access in the system, when we start accounting, we start taking a record of network resource utilization. We start taking a record of what you're changing. If you're configuring servers, then there are going to be logs that take a record of everything you're doing in the system. Now, in practice, I think one of the simplest applicable, most common application scenarios of AAA is with ISPs, internet service providers. They need to authenticate the account and password of a home broadband user, for example, before allowing the user to access the internet. In addition, the ISP will record online duration or traffic that the user is using. How many MBs have you transferred? How many MBs have you downloaded? How long have you been online? That is a typical and one of the most common application scenarios of AAA. Now, as you can see, AAA needs some kind of elements. There are some objects, some players that we need for AAA to be able to function. This is the common AAA architecture. There is going to be some user on some end who wants to access some network resources, and they are accessing them through a network access server, and there is a AAA server deployed somewhere on the network, probably in the data center, probably it's in the cloud, probably, as long as there is connectivity between the network access server, which is the device that you access the resources you want to access through. So a user 3, for example, will access the internet through the network access server. User 2 will access the internet through the network access server. User 1 will access through, that's why it's called the network access server. So we have the user, we have the network access server and the AAA server. So the network access server is going on behalf of the AAA server to collect and manage user access requests in a centralized manner. Now, there are normally multiple domains that are going to be created on the network access server to manage different users. Think of a domain as a grouping. So we have people in management, you have people in accounting, you have people in research and development, we have people in networks, in the core. We have different domains, probably have different rights and different, access rights and different authorization scopes and so on and so forth. So these different domains, in this case, we have domain 1, we have domain 2, and we have domain 3, are going to be associated with different AAA schemes, different authorization different authentication, authorization, and accounting schemes, which include an authentication scheme, an authorization scheme, and an accounting scheme. When we receive a user request, when a network access server receives a user access request, the network access server will determine the domain to which the user belongs based on the username. As you can see, this user is user 3, but we add the symbol and the domain to which the user belongs. So this is the full name of the user. It includes the domain name. So the network access server will then perform user management and control based on the authentication scheme, the authorization scheme, and accounting scheme configured for that particular domain. This is domain 3, this is domain 2. Now, every user has to belong to a domain. That is a must. There is no way a user can exist without having a domain. So if you find a user who is just John with no @ and then the domain, that user is going to be put in the default domain because every user has to be associated with a domain, has to be associated with some domain in the system. So the delimiter @ symbol is the one we use to separate the username and the domain name. So we are going to look at each of these 3 elements of AAA independently and see exactly what is happening here. But the idea is when user 1 tries to access the system, the network access server will look at domain 1 and see the authentication scheme, the authorization scheme, and the accounting scheme. But what are all these things that we're talking about? So let us talk about the authentication first. As I mentioned, authentication is a way that the system verifies you are the person you claim you are the device you claim you are, before it thinks of what it should give access to you, which parts of the system it should allow you to access. So authentication supports 3 modes. There are three modes. The first one is the non-authentication. The second one is the local authentication. And the third one is the remote authentication. And they are really as simple and straightforward as they sound. In non-authentication, we fully trust all our users and their identities are not doubted at all, and we don't even check them. It is the authentication mode that is most rarely used because, of course, of security purposes. We can't just trust everyone. So in non-authentication, you come to access, we give you access, you do what you want, and you go off. No problem. Now, in local authentication, which is the second authentication mode supported, in local authentication, we have user information stored but on the network access server. In this case, on this router, we shall have this user information, or we have user 1 who is in domain 1, we have user 2 who is in domain 2, we have user 3 who is user 1 at domain 1, so he's in domain 1, and his authentication mode is non-authentication. I mean, but this we shall have a table that shows the users we have and their domains. So when a user tries to access the system, this table is going to be on the network access server. That's why we call it local authentication. In this case, the network access server is the one that will function as the AAA server. It will do the authentication, it will do the authorization. Unfortunately, it won't be able to do accounting because of resource purposes on the network access server. The disadvantage is that the amount of stored information is limited by the device hardware. In this case, this is a router. You don't expect this router to be able to store information of thousands of users who access the network. It won't be able to do that because it was only how much RAM, a certain amount of RAM, and enough to enable it to perform its functions as a router. So unless it can perform this function of a network access server, of a AAA server, it can only perform that to a limited extent. The authentication mode is often used to manage login users that want to access the telnet or things like SSH, things like that, log into a device to perform some management functions. Now, remote authentication, the third one, is where the user information is going to be stored on a remote device. A device of the network the user is trying to access. Look at this network. User 1 accesses the network like that. User 2 accesses the network like that. And user 3 accesses the network like that. See, all users are accessing the network off of the authentication server, of the AAA server. That's why we call it remote. It's remote as in perspective of the flow of user traffic. It's remote. So in this case, user information, this information right here, is going to be stored on the authentication server, on the AAA server, which is remote to the network the users are trying to access. Things like the username, the password, other attributes are all going to be stored on the remote authentication server. Now, the remote authentication server is going to be deployed based on the deployment protocol you're using. The most common protocols, as I've mentioned, are Radius and TACACS. Now, we have our own implementation of TACACS that we call Huawei Terminal Access Control Services. So Huawei TACACS will be deployed on this server right here, and then it will manage the authentication, authorization, and accounting, or Radius server will be deployed right there to manage authentication, authorization, and accounting. That is why we call it remote authentication. You access resources right here, but you're going to be authenticated by a server in a remote location. Local authentication is when you get authenticated by a server through which you're accessing the network. Non-authentication is where we don't authenticate you at all. We trust you 100%. So that is what authentication is, the first A. The second A is authorization. So what exactly is authorization? As I mentioned earlier, when we authenticate you, yes, you're John, and yes, you are our employee. Okay, that's true, but which parts of this building are you allowed to get into? Are you allowed to get into the private drawer of the managing director of the company? Are you allowed to get into the rack and start restructuring the cables? Are you allowed to log into the router? Are you allowed to turn off the wireless to access the switch, the enterprise network switch? Are you allowed to do that? Are you allowed to get into the safe and count the money? There are places you are allowed to access and those you're not allowed to access. And likewise in the system, there are parts of the system you're allowed to access and parts that you're not allowed to access. That is the role of authorization. You have been authenticated. Cool. So now you're authorized to access room A and room B and corridor C and the washrooms. You can't access anything else. That's what authorization is. It has three modes also. There is non-authorization. So for non-authorization, as long as you're authenticated, you have unrestricted access rights on the network. Let us say you have a small office building that has how many? A few rooms, and all the rooms are really open and few workers. So as long as the gateman checks you, the askari checks you, and you are a worker, well, you can just get in and access pretty much everything you want to access in the building. Well, that is not always the case. Sometimes different workers are able to access certain parts of the premise and others are not allowed to access those parts of the premise. In that case, we would use either local authorization or remote authorization. We don't authorize you on authentication. After authenticating you, we need to authorize which parts you're authorized to use. Now, in local authorization, just like local authentication, it means that you're going to be authorized based on domain configuration on the network access server. The information that relates to authorization, authorized content, none. Internet access is allowed, granted by a remote server. Authorization mode, this information, the table that determines who is authorized to do what, is going to be stored. All of it is going to be stored on the network access server on a local device, a device local to your traffic flows. Now, in remote authorization, the information about authorization, what are you authorized to do, what are you not authorized to do, is going to be stored on a remote server, an authorization server on the AAA server. Of the flow lines of your traffic is where you're going to be authorized. So again, non-authorization authenticated users will have unrestricted access rights on the network. Local authorization is where the users are authorized based on the domain configuration on the network access server. And remote authorization is where we are going to use Radius or the Huawei TACACs to do the authorization. So in Huawei TACACs authorization, all users can be authorized by the Huawei TACAC server. It doesn't matter whether you were authenticated by Radius server or by Huawei TACAC server or by TACACs Plus, another vendor server. It doesn't matter. You can still be authorized by the Huawei TACAC server. Now, Radius authorization is a bit different because it applies to only users who are authenticated by the Radius server. I really hope that makes sense. Radius cannot authorize a user who was authenticated by a TACAC server. That cannot happen. So Radius, in other words, integrates the first A and the second A. It does authorization on authentication. As long as you authenticated, it will authenticate and authorize you in the same step. Therefore, Radius authorization cannot be performed alone. When you enable remote authorization, users can obtain authorization information from both the authorization server and the network access server. In other words, when you enable remote authorization, the information can be stored right here and also stored right here. What is going to happen is that you set up, in your configuration, you set up priority. There will be a priority of the authorization information configured. So you configure a lower one on the NAS and the higher one on the AAA server, so that we always use the AAA server. When it is not available, we shall use the network access server. So that is the first A, authentication. The second A is authorization. Now you're authorized and you are into the system. You can click what you want to click, type the commands you want, but we want to keep track in the system. What did you do in the system? How much did you download? How much did you upload? How long were you logged into the system? That is where accounting comes in. Accounting function monitors network behavior and network resource utilization of authorized users. It supports only two modes: non-accounting and remote accounting. Which mode is missing? That's right, local accounting is missing. Because of the reason I've already mentioned, we cannot store this accounting information on the network access server. It's normally quite a lot of information that increases quite quickly. The network access server will be overwhelmed. This is normally a router or a firewall or a switch, some device through which you're accessing the network. We can't store all this information on that device, and so we do not have support for local accounting. Accounting is either going to be non-accounting, where users access internet or network services for free, no activity log is generated, just do what you want to do and walk away, or remote accounting, where we shall be storing our information on the remote accounting server, through Radius or through Huawei Tacax. So these are the three items involved in AAA authentication, after which you get authorized, after which you shall perform accounting on your activity in the system. Let us look at one of the protocol, the most common protocol in which we do implementation of AAA, and that is Radius. So, of the protocols that are used to implement AAA, Radius is by far, by the way, the most commonly used. And what exactly is happening? Radius is a distributed information exchange protocol, and it is based on what we call the client-server structure or client-server architecture. We have a Radius client and we have a Radius server. So it implements user authentication, user authorization, and also user accounting. So generally speaking, okay, this guy right here is supposed to be the client, okay? But when we are using Radius, this guy right here will function as the Radius client. So he's speaking to the Radius server on behalf of the client. So that is actually what is happening. The network access server is working as a Radius broker. He speaks to the Radius server on behalf of the client and performs operations like accepting or rejecting user access based on information that the Radius server has returned to it. In this flow of information, you see that the user enters a username and password, and the network access server receives those and sends an access request on behalf of the user, sends an access request to the Radius server, waits for the authentication to be accepted or rejected, and the corresponding packet received to the network access server, which forwards the relevant message to the access user, to the user who is accessing. The user will be notified of the authentication result, whether it's accepted or whether it's rejected. Now, if the authentication is accepted, then the network access server will send an accounting start request on behalf of the user, for which the network access server will receive an accounting start response. That is the point at which the user will start to access the network resources. When the user is done accessing the network resources, they will send a request to go offline, for which a network access server will send an accounting stop request. On receipt of an accounting stop response, they will send the relevant notification to the user of completion of network access. This is the kind of exchange of data, of packets that's going to happen when you're accessing a network that for which the resources and access rights, AAA is being governed by a remote Radius server. Now, I'm giving just two typical application scenarios of AAA. First of all is when internet users attempt to access through Radius users are accessing internet through radius. In this case, you have an internet user who wants to use internet, but the network has a radius server to authenticate, authorize, and do accounting for the users. In this case, the AAA schemes will be configured on the network access server to implement interworking between the network access server and the radius server. After that, after the user enters a username and a password to the client is the network access server. The network access server will send the username and password to the radius server for authentication. And if the authentication succeeds, the user is granted the internet access permission. The radius server can record the user's network resource utilization during the period with which the user is accessing the internet. Another typical example is with us when you, the administrator, are logging into the network access server for management purposes through Telnet or SSH, that is local authentication and authorization for administrative users. So in this case, we would have local AAA schemes configured on the router or switch. And the router compares the username and password that the user enters when they are trying to access that user, in this case is the network administrator, with a locally configured username and password on the router. So when you enter username and password, the router will compare username and password with locally configured usernames and passwords on the router itself. And it will grant you access or deny you access depending on the match result. So the network administrator will log into the router. After authentication succeeds, the router grants certain administrator permissions based on the authorization configuration or the authorization scheme that is configured on the router in this case, or the network access server, which in this case is the router. And that, ladies and gentlemen, is the overview of authentication, authorization, and accounting. In the next session, in the next video, I'll go through typical configuration guides, typical configuration commands that are used for AAA. I hope this has been informative for you, and I thank you for viewing.